Hello everyone, you're welcome to physics class. This is Tony Chase, by the way, and the topic for discussion will be motion. What is motion? This is one age-long concept that everybody is very used to. You woke up this morning, walked to your bathroom, you took some exercise, the place of your fan rotates. Talk about moving a vehicle from one junction to another. All these exemplify motion. So it's not a concept that's alien to anyone. But the question is, how do we define it? What is motion from the technical point of view? When we talk about physics, it's not just the usual layman's language. So how do we define motion as pertaining to physics? Well, I could disappoint you here to tell you that motion is no different from movement. It's as simple as that. Movement. So you're wondering, why should it be that simple? Well, that's a concept. You go from your bathroom, like I said, like you wake up from get up from your bed and walk to the bathroom, you exhibit the kind of motion, all right? The car moves from one junction to another, simply motion. So, and that is a way of movement. So there's no big deal to that. Now the question is, what are the things we'll be discussing in motion? We'll look at the definition, which I just gave you in a nutshell. The types. What are the types of motion we have? Then you consider the major concepts of motion. Because the type is just a wide concept, we're looking at that very shortly. So, but for this class, we'll be emphasizing on linear motion. So let's just look at the types, and then we'll now go on and emphasize on linear motion. So, talking about types of motion, broadly speaking, you could say there are four: linear, otherwise called translational motion. We also have rotational motion. We call that rotational motion. Rotational motion. We have circular motion. We have oscillatory motion. And of course, we have random motion. Random motion. Now, some people may make an argument that there are still some other kinds of motion that we've not classified here. We'll get to that in a bit. So what's linear motion or translational motion? Translational motion is just simply motion on a straight line, a straight course motion. For instance, how would a train move from one terminal to another on its track? That's simply linear or translational motion. All right? It's difficult for humans to exhibit linear motion because we tend to walk, sway from year to year, we move about just freely. So it's very difficult for humans, unless they want to deliberately do it. Humans don't usually exhibit linear motion all the time, unless it's something deliberate. Okay, but a train on its track, for instance, will exhibit linear motion freely. So with a plane in the air, because there are little or no traffic in the air. But then a car on the road, how about a car on the road? Would that also exhibit linear motion? It depends on the distance being covered. If the car is just going from one junction to the next junction, probably on the straight course, on the straight road, yes, a car could exhibit linear motion on that concept. But then, generally, we talk about linear motion, what comes to mind should be what? Straight line motion. So, examples, I just mentioned a few. The train on its course, on its track, the airplane in air. Then, like I said, the car could also go from one junction to another if it's on a straight road. All right, so those examples will suffice for linear motion. How about rotational motion? Rotational motion is simply a concept that people confuse for circular motion. These two are very, they will call them, it's a little gray area here. You have to just demystify the two. So what about rotational motion? A body rotates if it moves about its own axis. Its own axis. Now compare the way the blades of the fan move about a central hub, the central part of it. That is rotational. Because there's no external body, it's just the blade of the fan moving about the central hub. That's rotational motion. How about the tires of the car while in motion? The tires of the car exhibit rotational motion while the car is in motion. The movement of the earth. Now the earth does two kind of movements. One is rotational, the other is revolutional. Sorry, I meant to say, revolution, you can say it revolves about the sun. So one is rotation, it goes about its own axis, spinning about its own axis, causing night and day. And at the same time, it goes about the sun. So doing that will be classified as circular motion. We'll get to circular motion in a bit. So rotational motion simply means the movement of a body about its own axis. Talk about the tires of a car. Okay. Talk about tires of a car. Right. Talk about blades of a fan. Blades of an electric fan. All right. These all exhibit motion. How about the rotation of the earth? Rotation of the earth. About its axis. All these exemplify rotational motion. Now let's talk a bit about circular motion, because like I said, the emphasis of the class will be on linear motion. We can't pick up all of this and discuss in one class. So let's just talk about circular motion in a bit. Now circular motion has to do with the motion of a body about another body. Okay, so there is a body and it is moving about a remote body. Let's talk about a car in a roundabout. Everybody knows about roundabouts. When a car goes about that, it's exemplifying circular motion, because you don't compare that to rotational. Rotational is spinning about its own axis, like the blades of the fan about the hub, the central part of the fan. Now, with a car moving in a moving in a roundabout, that's simply circular, because there's a car, one body, and then there's what the roundabout itself. The car goes around it, describing circles around it. The same way, so I'll just call that a car in a roundabout. Okay. And talk about revolution of the earth about the sun. Okay, the earth and of course the other planets revolve about the sun. The sun is one body, the earth and the planets. Okay, let's just pick the earth. Okay, the earth is a body, the sun is another body. The earth does circles around the sun. That's a clear case of circular motion. So if you look at it, so I think it's clear enough to say this is a body revolving about itself, while this is a body going about another. That's circular motion there, and these are examples. How about oscillatory motion? Oscillatory motion has to do with a to and fro kind of motion. Think of a swing, the swing on a playground. Think of a pendulum ball. When you tap a pendulum, it swings to and fro. Let's just make a sketch of that. All right. Okay, so here is a string, an inextensible string. There is a bob. You give this a gentle tap, what happens? You see it swing forth and back. And this is a clear case of oscillatory motion. All right, so a pendulum exhibits oscillatory motion. A swing does the same. So this is a kind of forth and back motion is simply called oscillatory motion. And someone would argue, how about vibratory motion? Okay, so I have not listed vibratory because it should be discussed under oscillatory motion. So what's the difference between the regular oscillatory motion and the vibratory motion? Now with the regular oscillatory motion, you could see that the amplitude of the swing is quite pronounced. Alright, the swings here, quite clear that this is a wide swing. Okay, you tap a pendulum, it swings this and swings forth and back. The amplitude is quite pronounced. But when you look at the way vibration occurs, let's imagine there's a table here. This is a tabletop. And I hold down a ruler, for instance. I hold down a ruler at the edge of the table and I tap this other end. What would happen is that you find that the ruler begins to vibrate. So that is a kind of oscillatory motion, but more appropriately we'll classify that as vibratory because the amplitude of the oscillatory motion here is quite small as compared to the regular oscillatory motion. You see this swings quite clearly. Everybody knows there's a big displacement from this junction to this. But with vibratory motion, that amplitude is quite small, and then it occurs more regularly. The period is so small as compared to the period of vibration here. So that's why we have this kind of a subsection of the oscillatory motion, but you could argue that it's another form of motion on its own. So vibratory, so you would say a tuning fork, you could say as example a tuning fork in vibration. Some people don't know tuning forks. Okay, for the sake of this discussion, then we'll just list it. We'll come to discuss it in future classes. Tuning forks. Talk about, you could say, a guitar string pulled, a plucked guitar string, Plucked guitar string would be a very good example of a vibratory motion. But let's cite examples of oscillatory motion. Talk about a pendulum. We talked about a swing earlier on, a playground swing, and so on. These are examples of oscillatory motion and the vibratory motion. And finally, we have the random motion. I joke that this is one of the most, would I say, unclassified or the most useless of the kinds of motion we have. Because in physics, just as it is with other sciences, we do not reckon with anything that doesn't have a pattern. We scientists like to study things that have patterns so that we could document it, and then we use that to as inference for other instances that align with that former one. So yes, random motion, a motion that is unpredictable. So what do you gain from something that is erratic, something that changes every time? If I drop a piece of paper from this height, it could land anywhere. And I could repeat the same thing for 20 times, and there's no guarantee that the paper will land on the same spot twice. That's random motion. So, okay, as I said earlier, a piece of paper dropped from a height will pass for random. A piece of paper dropped from a height. Okay, dropped from a height. All right, that's an example of random motion. What else can we say as a random motion? Look at smoke particles. Smoke particles. Okay, smoke particles can feel everywhere at the same time. So these examples, this ones just exemplify random motion. Motion without a particular pattern, erratic, unpredictable. So I've just given you an overview of motion.